Okay, so let's go back to our original question. So here we have 4 classes. So it seems like class 1 do averages better than others, right? So here we want to check whether the evidence is significantly or significance. We just check the significance of evidence. Okay. So here we compare 4 classes. So this is a many sample problem, right? So we say we use ANOVA, and so here at the first for compare many groups or many samples. So at the first we need to check this HO. HO is no difference. Okay. So the logic is just like that. If HO is true, then we just simply say no difference. All those 4 classes are quite the same. So if we reject HO, if we find they do have some difference, then maybe we can say, oh, class 1 is better than other class. Okay, or maybe like class 2, class 3, class 4. These 3 classes are quite the same, no much difference, but class 1 is clear above them. So just like that, class 1 is a group. So class 2, 3, 4. So these 3 are quite the same. So our conclusion just like that, right? So class 1 perform better than other class, and among other classes, the difference is not so significant or quite the same, right? Okay, so we say for this hypothesis of a test statistic is F value. We need to check F table, and F value is A is G over df1 divided by A is E divided by degree of freedom. So what is the degree of freedom? What is df1? Df2. So we say df1 degree of freedom for SSG is k minus 1. So here is k is how many groups we compared. So here we compare 4 classes, right? So 4 minus 1 is 3. So df1 is 3. We say degree of freedom for groups is 3 because we compare 4 groups. So then what is the degree of freedom for F2? So we just remember there's 2 degree of freedom, add them together is equal total degree of freedom. Total degree of freedom is n minus 1. So here n is total number of number of the sample size. We just put 4 classes together, or 4 samples together. So let's say, so how many students? So we just check together, put 4 classes together. We find we have 88 students, right? So here n is 88. So here we just put 4 classes together as 1 class, 88. Okay, so then we say total degree of freedom 88 minus 1, 87. Okay. Okay, so this equals 3. So then df2, or we say degree of freedom SSE is 87 minus 3 equal 84. Okay. So we can easily at the first determine those degree of freedom. Okay. So here we say we get this degree of freedom. So here's a different formula, but anyway we get the same answer, right? So degree of df1 is k minus 1. So once we determine k minus 1 degree of freedom in numerator, we can easily determine the degree of freedom in denominator, right? So then we need to calculate what is SSG, what is SSE. So now let's focus on find SSG, then find SSE. Okay, so what is SSG? How can I find SSG? Remember, SSG is we put those data like we assume in this direction no variance, only changing or no changing, only variance or changing will come from this direction, right? So we assume like class 1, all the numbers in class 1 in class 1 all the data are the same, all people, their exam scores the same. So same equal what? So we say just 84, like 84 like this. Okay, so in this way, like this direction no change, right? So in class 2, the same way, like we assume like so within class no difference. The class 2 is like 81. So data just like that, 81. Okay, or 81. And the class 3, the class 4 is let's say people the data is 80, just looks like that. Everyone is 80 in class 4, so 80. So SSG is this SST for such data. So we can say SSG equal, let's say so just like each one minus average square. So 84 minus average, this average square. So 84 minus the plus another 84. So how many 84? We said 25 84, right? In class 1, I remember class 1 students number we have 25, right? 25. So 81 we have 81. So plus 20 of those 81 minus average square, like this, right? So this average X bar is average for all students. So we call this average as a grand average or grand mean average. Okay. Okay. So at the first we need to find this grand average. So we have average for each class. Like our class 1 average is 84, class 2 average 81, like this. Then we can have like average for all classes. Put the 4 classes together, what is the average? So this is a current average. So this average we just calculate this way, right? Calculate this way. We say average. What is the average for all students in these 4 classes? So we also consider this average the weighted average of. So we have 84, we have 84, 81, so 82, 80. And the total average should be weighted on the number of students. So here 25 times 84, 20 times 81, so 22 times 82, like this, or then divided by 88. Also, we can say this average is just like this average. Suppose data like this. So what is the average? So just 84 plus 84 plus 84, so we have 25 84. Then plus 81, 81, 81, we have 20, 81, right? Then divided by, add them all up, divided by total number. Okay? Okay, so we get this average. So we can say average for all these 4 classes is this. Then we can find SSG. So SSG equal like 81 minus square. Then how many those 81? We say have 25. Then 84 minus, then 81 minus this square. So multiply 20. We have 20 so many numbers. So 82 minus the square 20. 22, like we have 22 those numbers. And like 80 minus the square, so we have 21 of this, 21 of them. So here we have this formula. SSG, we can use this formula. Okay? But we don't need to remember this formula. We just need to understand this formula, right? So we can get this. So after a little bit of calculation, we found SSG equals this. 202.4. So then we need to find SSE, then find F value, right? So what is SSE? So SSE, we say SSE is in this direction. SST for this direction. So for class 1, so we have this data class 1, right? We say class 1. And then class 2, so we just check this direction, right? Okay, so check this direction, the SST for class 1 is like each number minus average. So here just xi minus average. So here average 84, right? The square divided by n minus 1 divided by 24, right? Oh, I'm sorry. This is s square, right? So this actually is S1 square. So variance from class 1 is this. So this numerator part is just the SSE in this direction. SSE, so this part xi minus 84, so for class 1, so equal 24 multiply S1 square. So S1 square we already know, right? S1 is, let's say, S1 is 7. So S1 square is 9. No, I'm sorry, 7 square 49, right? Okay, so this is SSE. So actually, so we can say like this is SSE, this part from class 1, then from class 2, then from class 3. So we have this formula. This number is just n minus 1. So n1 minus 1 multiply S1 square. Like 24 multiply 7 square. So plus 19 multiply 9 square, right? So 9 square the variance. Then 21 n minus 22, right? 22 minus 1, 21. So multiply 8 square. And n 20. So n4 is 21, so 20, right? So multiply this variance, 6 square. Okay, so we found this is 4770. Oh, 4779. Okay. Okay, so then we can have find f value. So f value equal, so this equal, it is g over degree of freedom for 1, df1, the df1 is 3, and df4 is 84. So this equal just 2.4 divided by 3, then this number divided by that, 4779 divided by 84. And then we get this number is 1.18. So this is our f value. So now we need to determine this is big number or small number. So if there's a small number, then we can say like the difference is small. And we also can check like so let's say, so here we determine this big number or small number. We have two ways, right? We can use a p value. We also can use a critical value. So critical value. So those two things are quite almost the same. Yeah. So here we try to find a critical value, and this is critical value from F table. So we just call this as F critical value. So how can we find this F critical value? So here we say we check degrees. Here degree of freedom 3. So here degree of freedom 84. Then this number is F critical value. Okay. So let's go to the F table, find this critical value. Okay, so here degree of freedom in numerator is 3, degree of freedom in denominator, okay, go down to 84. But we do not have 84. df2 is 84. Okay, so we do not have 84. So then we just check a close one. So we on close one, I think is 60, right? So I just check this. Okay, so we find the number is this. Okay, like a degree of freedom, let's say df1 is 3 and df2 is 84. So this number. So this 2.7581, this is a critical value. Okay, so use this critical value, we will determine the test statistic is big or small. Let me write down as the 2.75. Let's say I will forget in my memory. Not good. 2.7581. Okay. So based on this, we say 2.7581. Use this as our standard. Then we can say, oh, this number is small. Okay, right? Okay, so we can say if this is small, then we say the difference is not so significant, and this is, so we can say there's 4 classes. Their performance quite the same, and we cannot say class 1 is the best one, right? So can we say, so we say even though we have some evidence, but simply this evidence is not strong enough. Okay, so we finish this example 1. So this is typical problems for many sample problem, right? For compare many sample. Okay. So for those problems, we just need to find if values and determine this if value is big or small, right? Okay. So from some computer output, we will computer output will give me this if table, ANOVA table we call like give me S is G, S is E, S is T, like then we can find this if if value then determines big or small. Okay, so now let's say so here we say so like let's say we have those things like S is T, S is E, like we have those things like let's say we have a ANOVA table. ANOVA table is just like that. What is S is G, so S is G, S is E, and S is T. Saying degree of freedom. So what is degree of freedom? Saying divided by the degree of freedom, we also call it this MSE. Now MSG, MSE. Saying MSE or MSG over MSE is F value, right? Okay. So now let's consider this problem. It says we from computer software. So find S is G, find S is E, find S is T. Sometimes the calculation is tedious, so we usually use a computer to do those. So now let's consider this problem. So we already know, or I just tell you S is T equals this, S is E equals this, then make a decision. So can we conclude that these treatments are essentially quite the same or not the same? Okay, so let's say so we just need to find F value, right? Let's say here find F value. So F value is S is G over degree of freedom, so S is E over degree of freedom. So let's say what S is G we already know. At the first we need to find S is G. So what is S is G? S is G equal S is T minus S is E. Okay, so let's say so this equal. Just do a little bit of calculation. Yeah. Okay. 6, 7, 8, 9. I think it's 1, 6, 7, 8. Okay. 1, 6, 7, 8. Okay. And so what is degree of freedom for group? Then we need to check how many groups we compare. We compare how many groups. Okay, so it says we compare 6 treatments or 6 drugs. So DF1 is 5. So here should divide by 5, right? Saying what is degree of freedom for denominator or degree of freedom for SSE? Then we just check, okay, so totally how many, let's say, totally how many, the total, what is the sample size, total sample size. So let's say, we compare 6 treatments. Each has 20 patients. So let's look like that. Here, okay, 1, 2, 3, 4, like 5, 6. We compare 6 groups. Each one is 20. So totally, we have 6 multiplied 20. We have 120 patients, right? So this is total sample size. Okay, then total degree of freedom is 119, right? N minus 1. Okay, so if this is 5, then this is 114. Okay, so at the first, we just determine the degree of freedom. So this degree of freedom 5 and 119, right? Okay. Okay, 119. Okay, so what is SSG? I will just plug it in here. 1678 over 5 divided by what is SSE? SSE, we already know, like SE is 6789 over 119. Okay, so then we need to do a little calculation. Okay, so find this. This is our f value. Okay, so let's say 1 6. I'm sorry. Okay, 1 6 7 8 divided by 5. Okay, so this is okay. Then 6 7 8 9 divided by 119. Okay. 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 So then okay. Okay, I find that so the f value is just 5.89. So then we just determine this is big number, small number. So we just compare this number with the critical value. So we just check out what is the critical value. If critical value, so check F table. We go back. So F table. So F table, we have 2 degree of freedoms, right? 5 and 1. I'm sorry, I made a mistake. Oh yeah, I made a mistake. Here's 114. Oh, then my calculations wrong. Yeah, 114. So maybe this is wrong. So the calculation mistake, yeah. So let me do this again. Okay. So this is okay. Okay. 6 7 8 9 by 114. Okay. Okay. Then let's see. Okay. This equal 5.63 or 64. So here's just a calculation issue. Yeah. Okay, so then determine this is big number or small number. So we just check F table. So here F table, let's say degree of freedom 5 and 114. 5 and 114. Okay, so we go back to F table. Okay, 5. So here 5. There's a column 5 and 114. So 114 degree of freedom, df2 is 114. So we do not have 114, so we just pick a close one. So we just pick this, right? 120. So 5, which one is column 5? Okay, we find this one, right? So this is the F critical value. Okay? Okay, so compare with this 2 point, let's see. So we compare with this, we find 5.6 is big. So we can say this is a big number. Okay. Then our decision or our conclusion is these 6 drugs or 6 treatments do have difference, right? Okay, so then we can check for them more whether these 6 drugs difference which way. Maybe like this drug 1, drug 2 quite the same, drug 3, drug 4 maybe quite the same. Like we also we call those process as a partition. We split 6 drugs into parts. So within part, no much difference. So maybe our conclusion can be like this, right? Oh, drug 1 or 2, no difference. 3 and 4, 5, 6, this other group, no difference. And okay, so we just put this 6 treatment, our conclusion maybe like this way, right? Okay, so but anyway, like for those detail check, we will not go furthermore. So here we just check whether they're same HO or whether they are the same or not the same. Okay, so this is topic for many sample problems. So for many sample problem, we just check out whether they're same or not the same. This is for our first step, right? So for many sample problems, for check this, we use ANOVA. And also, so we call those tests as ANOVA test. Or because this test, we check a if table, so we also call it the if test. So ANOVA test and if test is the same. Okay, so we calculate this number F value of this test statistic, and then just determine this big number or small number. Compare this test statistic with critical value, right? So we can see that from here we can see the basic idea quite the same, right? We do some calculation, find the test statistic, then determine this big or small, right? Okay, so this is today's topic. So we finish this topic. So we call this many sample problem. Okay, so we can stop here. And so so enjoy your Thanksgiving. Okay, and thank you for watching the class lecture video. Okay, thank you. So we can stop here. Thank you. Bye bye.